Yep.
Okay.
Should just happen. It still says starting. I don't know if that means it's actually is doing that now.
It says on my screen it has started. So
All right, excellent. So I guess we're going to learn about conserve-socket.
okay. So yeah, let's go for it. My name is Alberto. I think you've met me before, and we wanted to share with you some of our impressions with playing with this setting in Geode, which is conserve sockets. So I have a presentation. I'm going to share my screen. Let me see if I can share it. Okay. Tell me when you can see the screen.
It's there.
Okay. And you see the first slide now? Is it going forward, right?
Yep. It says conserve-sockets definitions. That's what
Yeah.
should be there?
Yeah, that's it. Okay, so I wanted to go through first what is conserve sockets according to the documentation of Geode. So in this first slide, this is what we get from the documentation. It's a setting about the connections between threads in Geode. And if you set conserve sockets to true, then the threads that exchange information to handle client requests will use these already established peer connections, will share these sockets. But if you use conserve sockets to false, which is the default value since 1.14, I think, then each thread that services clients will establish two of its own individual connections to its server peers, one to send and one to receive. So this is what this parameter is about. Some more information about the advantages and disadvantages of setting one or the other value. Again, from this documentation of Geode, if you set conserve sockets to false, then well, that will alleviate socket contention between threads because you will have more connections. It seems that it's going to optimize distributed ACK operations for distributed regions and for, well, there's some optimizations. And for partition regions, it's supposed to enhance the general throughput. While if you set conserve sockets to true, well, the demands on system resources will be reduced. It seems that the performance will be slower of the system, and you will have a higher risk to run into distributed deadlocks. Some more information about conserve sockets. There is two places in which you configure this setting. There is one at application level. There is one global parameter in which you can set conserve sockets to true or false. And there's also a thread level. If you have a server function and it's executing in a thread and you want to override the setting, then there is an API with a method called setThreadsSocketPolicy. And with that, you can enable or disable the sharing of these sockets for whatever reason you want. There's also an API to release the threads once they have been used, but that's not something that is mandatory. The threads, if sockets are created because of this policy in your function and you want them to be released immediately without waiting for a timeout, then you should release them explicitly with this API call. There are some other details. Some are not so nice because they are a bit hidden, and that's something I wanted to share in this slide. One, well, is what we have talked about before. There is application level, which is a global way to set conserve sockets, and there's also a thread level. So even though you set a global value for this parameter, maybe some threads executing in your server will have the setting in another level. Also, in this article by Barry Oglesby about threads used in Apache Geode function execution, you discover that it's not so easy to really know once once you are running traffic in a geode cluster, if the conserve sockets will be, the global setting will be used or not, because sometimes your application code will be running one type of socket, for example, a server connection socket, but some other times it will be running a function execution thread, and in that case, the conserve sockets global setting does not apply. You have to set it manually. So it's sometimes a bit confusing or a bit difficult to know exactly how this setting will be applied in your system. Also, some detail we discovered while looking at the code is that even if you set conserve sockets to false, so that the threads are created on a thread basis, if the system detects that you have run out of file descriptors, it will switch off the conserve sockets setting that was set to false, and it would apply it. It would change it to true, and that would not be changed. I guess a log will be shown in the logs, but it will not be changed. So that was something that was a bit unexpected for us, but that's the way the system behaves. And there's another detail. There's these domino threads. This is something also inside the code, inside comments, but it talks about threads that are created on demand when you are using conserve sockets to false. If one operation in the cluster needs to do several hops, because, for example, imagine you have to do a put, and then you reach one server, and that server doesn't have neither the primary nor the secondary bucket, then it will have to go to the primary bucket, which would be on another server. So that would be one hop. And then in order to replicate the data inserted in a primary bucket, in order to replicate it in the secondary bucket, it would have to do yet another hop. It will create another thread. And these are what are called in Geo domino threads. And there could be several levels. According to the code, also according to some comments in the code, even if you configure conserve sockets to false, when you have these kinds of domino threads in which there are several hops, once you have done 2 hops, then in the next hops, if they are necessary, the conserve sockets set to false does not apply, and then in that case, the shared sockets between peers will be used, and no extra threads will be created. There's a setting to override this behavior, but it seems to be there by default. Actually, we are not so sure if this is working, because, I mean, by inspecting the code, we weren't so sure if this was really working this way. But there is some information inside the code in comments about these domino threads stuff. So these are low-level details about the conserve sockets that also make a difference on how the system behaves. Now, if we go about the recommendations, we have found these notes in the Geo documentation about this setting. And the first one is that one deployments increase the messaging demands on a geode system. So it is, well, I wouldn't say recommended. It looks like it's mandatory to set conserve sockets to false in case you have deployments with one replication, in order to avoid hangs in the system. This is what the documentation says. Also, from the documentation, another thing we found is that if you have transactions on empty, normal, or partition regions, and I guess partition regions are the most common ones in Geode, it also says that you have to make sure that you are using conserve sockets set to false to avoid distributed deadlocks. So according to these recommendations, it looks as if you will be in a high risk if you set conserve sockets to true and you are using one replication, or you have transactions in partition regions. This is what the documentation says. Well, this is a bit small. I hope you can see it, but this is something we extracted from VMware's support page, and it was about a recommendation to set conserve-sockets to false, not only as a global parameter, but also in those client threads implemented by the client, those server functions, because according to this documentation and according to the code, this conserve-sockets to fall is not honored always inside server functions. There are some cases in which you have to set it explicitly, as I said before. So according to these recommendations, you should do it for your server functions. And it also recommends to release the threads once they've been used. So yeah, this is another source of information about this parameter. And well, I think this is the last page about recommendations. Of course, you know that maybe it was about 1 year ago, Donald Evans started a discussion on the mailing list about changing the default value of this parameter, because before this discussion, it was set to true, but it seemed that it was safer to set it to false, because it seemed that for most customers, this would be the safest option. Even though, as I wrote here, well, you have the link here to the discussion in the dev list, but even though there were some concerns also about setting it to false, because setting it to true or to false has given issues in the past in customers in different ways. So for example, like here, John Blum was talking about the downside of setting conserve-sockets to false, but at the same time he was talking about the risk of deadlocks with conserve-sockets to true. It's not clear to me if this was something from the past, this deadlock, or this is something that should be taken into account. But yeah, again, the information, it's not so clear. I mean, John was, when he wrote this message in this discussion, he was asking that at least we should make sure that the documentation was quite clear about the limits that were required in different cases. So, well, he ends this email saying that this has caused enough grief in the past, both ways. So, yeah, this is quite tricky to really know exactly what value to set in conserve-sockets. And this is, I think, the last thing about what we've found about conserve-sockets. I found this test case in the Geode distributed test cases. This is one test case which apparently, well, it's one class with 4 test cases, and it says that the 4th test case, when you set conserve-sockets to true, it hangs, fails, and it is commented out. Actually, the test is not commented out. I mean, it can be run. I've run it several times, and it doesn't hang. So I don't know if this was something from the past, some limitation with conserve-sockets and one replication, because this seems to be related to well, there is a serial gateway sender, and it talks about the deadlock. So I don't know, for example, if when we have these notes in the documentation about deadlocks and about hangs with conserve-sockets to true, it was related to something in the past which was fixed, because could have been this test case, the one related to that, or maybe there is something else, but I haven't found any test case in Geode really pointing to these deadlocks that are mentioned in the documentation, and also, for example, in the email sent by John Bloom. Yeah, one or two more slides about conserve-sockets. If you set conserve-sockets to false, there's some implications, and the implications are mainly on system resources. And this is a table from the Geode documentation in which you are instructed on how to estimate the number of sockets you will need per member. If you set conserve-sockets to false, so you have one table here with a number of servers, it's not so easy really to do the estimation, because in the last row there is this summation over n-1 other members of t times 2. Well, actually, it's saying that you have to also, to these formulas you have above, you have to add a sum of the connections you will get from other members. But those connections you get from other members, really, it's not something that is easy to estimate, because these, when you are using conserve-sockets to false, then threads are created on demand and connections are created on demand. So really, I don't know, I don't think this is totally clear, and at least it wasn't for us before we run some tests with conserve-sockets to false. But there are big implications in setting this parameter to false. Okay, so this is it about the information we got from the documentation in Geode. And after that, we wanted to share our experience, and if possible, then get some feedback from the community about this setting and about our tests. We have, we have run some tests with a Geode cluster with 16 servers. The max number of threads is quite limited. We are setting this to 32. These are the threads which are assigned to handle client requests. I don't know if that's the correct name, client threads, but these are threads in the server to handle client requests. We have traffic with gets, puts, transactions, and mainly server functions. Those operations are done on partitioned persistent regions with one redundant replica, and also with replicated persistent regions. And we are using one replication. We did these tests because we had been using Geode with conserve-sockets to true. And according to the documentation, that was not really the right approach, because we at least were using two features of Geode that seem to be not suitable with conserve-sockets to false, which are one replication and transactions on partitioned regions. So we ran these tests, and we wanted to observe at least what were the number of connections that were created between servers. So with conserve-sockets set to true, then the number of connections between each pair of servers was 4, as expected, because the connections between peers were shared by all the threads. That's what the conserve-sockets to true is about. If we set conserve-sockets to false, but our clients were honoring single hop was set to true, then what we observed is that the number of connections between each pair of servers, it grew to a number of 90 connections, which more or less it could be extracted from the formulas I showed before about the estimation of the number of sockets you would require in your system. But if we did the same test, but with our clients with single hop set to false, or with some issues that were provoking that the clients were not reaching the right server in the first hop, then we could see that the connections between each pair of servers grew to a number of 900. You have to take into account that this number depends a lot on the amount of traffic that was received by the cluster, and also by the number of threads that were handling client requests. Probably, if we sent more traffic, or if the max number of threads was increased to a higher number, the number of connections we would see here could be much higher. And one last test we did was to set conserve-sockets to false, then have our clients use single hop to true. but have one server struggling, one server that was, for any reason, responding more slowly than the rest. In that case, what we observed was that the number of connections between each pair of servers was around 90, like in the second case, but the number of connections from and to the non-healthy client grew to 400. So these were our observations from these tests. This is a summary of the observations, and yeah, apart from the number of connections, what we observed with conserve-sockets to true was that we didn't observe any deadlocks other than bugs we have found and fixed, but nothing related to what the documentation was saying about conserve-sockets set to true and one replication and transactions over partition regions. That was what we were using, and we didn't observe any deadlock, and the performance was reasonable. When we set conserve-sockets to false, we saw a small increase in latency, but it was very small, so we don't know if it has to do anything with this setting, or maybe it's something we need to look into in our infrastructure. What we saw, as I showed you before, was an unexpected high number of connections and unexpected, or maybe a high number of peer-to-peer reader threads, which are the ones which are created when you use conserve-sockets to false. And that number was very dependent on several variables. And it was hard. Sometimes those variables are not in your hand. For example, if the clients were setting a small timeout for their operations, and their requests were timing out frequently, what happened was that the clients were needed to update the metadata, and while the metadata was not updated, you would get many operations not reaching the right server. You would need a hop, and in that case, the number of connections required would grow. Of course, as I showed you before, if the clients have single hop enabled or not makes a big difference in the number of connections that could be created. Without single hop, the number of connections grows a lot. Then the logic of the server functions, I mean, if you have server functions that are doing several hops, in each hop, with conserve-sockets to false, you will have to create a specific or use new connections assigned to that thread, and a remote peer-to-peer thread on the other side. So this will also make the figures of connections change. Optimize for write in functions. Again, if you optimize for write in functions which are doing writes is not set to true, then functions will need again several hops to perform the operation, and that will also make the number of sockets required and the number of connections between the peers grow. Also, if there are network or server disturbances, as I showed you before, if there is one server which is slow because the network is slow there, or because it's acting slowly, the number of connections grows. And also the number of connections in clients. If clients do not have connections to all servers, for example, then you would see again that the operations will not reach always the server hosting the bucket for the data it's going to act upon. So again, hops, and that will provoke that more connections will be created. So from this experience, we wanted to also create some discussion and also share with you some questions about what we see about conserve-sockets. And these are our questions. The first one would be if the deadlock cases are clear with conserve-sockets to true, because we have seen that in the documentation. The documentation says so, that you are in risk of running into deadlocks, distributed deadlocks, if you set conserve-sockets to true with one replication and partition regions and transactions. We have this test case, which seemed to be something that was provoking a deadlock in the past, but it doesn't look like that. So yeah, we wanted to ask if any of you know of any clear case in which you will run into a deadlock, because if so, I mean, because we haven't observed that. The other question we wanted to ask, I mean, I will read the questions and then we can open the microphone and anybody could comment on this, but I will share them before. The other question we had was, is this architecture with conserve sockets to false allow the system to scale? Because the more servers you have, the more threads you have, the number of connections is going to grow a lot. It's sometimes depending on your, as I said before, depending on a number of variables, the number of connection is not going to grow linearly as the servers or the threads grow, but it could grow quadratically. And we really wonder if the conserve sockets to false brings an architecture that will allow the system to scale. We don't know, because we have tested with 16 servers with a small number of threads, but maybe with 100 servers and with, I don't know, an unlimited number of threads, which could be an option, then we would run out of connections very soon, or file descriptors or whatever. And also one question related to this one would be if conserve sockets to false is suitable for cloud deployments, because in cloud deployments, it's not as in a native deployment in which you have control or more control on the resources you have. Maybe in a cloud deployment, it would not be acceptable that you open so many connections between servers. So yeah, these are the questions we wanted to discuss with the community, and I will stop talking now, and anyone is welcome to comment.
I think there is a question also, Alberto, in the chat.
Okay.
I try to answer, but maybe you can double check.
Let me see. Maybe I will stop sharing. It will be easier for me.
Yeah, I think Anthony was asking what the timeout was set to for the peer-to-peer connections when you tested.
Yeah, you are right, Evaristo. It was 60 seconds. Yeah, we thought about lowering this value to a small value, but anyway, at some points in our, and also if you have it to a very low value, but your system is requiring continuously to open new connections, then might not be the best case. So we thought it was reasonable to have this 60 seconds value.
Hey, this is Anthony. I could offer some thoughts on some of these questions you have, and other folks feel free to jump in. But regarding the deadlock case, if I recall correctly, I believe it is in situations where you would have call like a cache listener. Whether it's a reader, writer, something like that, that is doing other region operations in the callback. I think that is a situation that could more easily provoke a deadlock. And so that's why that warning has been posted. But perhaps someone has a better memory than I do about use of or encountering deadlocks in conserve-sockets true systems.
Yeah, the thing is that according to the documentation, it's quite restrictive, because if you have partition regions and transactions, which I think it's a very common case, then I mean you must be using conserve-sockets to true. Otherwise, it's, to false. Otherwise, it's quite scary what the documentation says. But maybe the documentation should be updated to have something more specific, because if it's a matter of a cache listener, then maybe that's not the most common case. But right now, it seems that you are restricting most of the customers to set it to false. But at the same time, setting it to false, we see we can foresee issues with resources, and also in cloud deployments. It's very hard to justify.
Okay. Yeah, maybe for the deadlocks question, we can ask that more broadly on the dev list to get more insight into some of the dangers that we've seen in the past with this. If I were to, the places where I've seen conserve-sockets true used, it was in deployments where the workload pattern was such that there was a very low cap on absolute latency. Like the max latency could never be over like a very, very small value. And so with the advantage with conserve-sockets true is that the socket connections are established and maintained. Whereas with conserve-sockets false, depending upon the value of that idle timeout setting, you may need to establish a new connection for a peer-to-peer message. And anytime you have to do that network operation, you're introducing some level of uncertainty and lag into that operation. So my experience with conserve-sockets true has mostly been in systems where that cap on latency has been a super hard value. The workload, they ended up using some extremely small heap values, like I think it was like 8 gigabytes even, to just keep the GC pauses small and try to drive out every aspect of latency that they could. That's the typical pattern I've seen for people using this. I don't know if that is helpful. I'll pause here if anyone else wants to jump in, and then we can talk more about the resource usage and things like that.
I guess this is maybe only tangentially related, but something I noticed recently. There was an oversight on my part when I had the pull request to change the default value, that we have quite a lot of tests that explicitly were setting conserve-sockets to false, and they had counterpart tests, but they didn't explicitly set it to true because they assumed the default was true. So I only just noticed that this was the case, and so we actually have quite a few tests that should be explicitly setting it to true that aren't. And so, yeah, I need to make a ticket for that. But so, okay, like currently there are tests that are not actually exercising the conserve-sockets true behavior, and so if there were problems in those tests, we wouldn't be seeing them. So yeah, that's just like a small testing gap that we have.
Maybe if I can comment, I think in our case, the only feature that we found deadlocks, let's say, easily reproducible, was continuous query. And I mean, we abandoned that, let's say, okay, a long time ago. And we saw, well, I don't know, some issues, and we decided to go in a different path. And actually, we have been running with this configuration for, I mean, I would say now many months, years even, in quite a bunch of customers. And we don't see the pattern, okay? But with continuous queries, it's true that we abandoned that because we found problems. But with the rest, that was not the case. And in our case, at least, I mean, maybe it's a bit special, but I mean, like we have behind some infrastructure at virtualization. At the end, you have layers that are putting boundaries on your resources, okay? So then it's becoming tricky, okay, to be unpredictable, because in some areas you can be bounded, so you need to talk with, I don't know, special configurations depending on the size of the customer and so on. So, I mean, this was like a nightmare for us. So we followed this path and it was okay, actually, quite good, I would say. So.
You mean conserve sockets to true, right? Evaristo?
Yes, to conserve sockets to true. So, I mean, but obviously we don't have the experience that you have, but more or less, just to complement a bit what Alberto commented. So, and that's the tricky part also for us, that, I mean, the number of resources that we observe with 16 servers is high, okay, because you have, worst case, Alberto commented, almost 1,000 per server, you have 16, so 16,000 plus the clients, 15 servers, but if you go to 45 servers or 50 servers, then, I mean, this is becoming, I don't know how to, scary, I would say. Probably I don't know, we check our limits, hard limits by the infra, and we surpass in that case. So, I mean, this is more or less our internal debate. Especially, I think it's very relevant if you go to the cloud, as Alberto commented. I don't know. At least for us, it's a hard decision to make with the information that we have to make the change.
It's true that if the pattern is to create the connection and then destroy it, then maybe the number of connections will be much slower. But I don't think that we will meet our latency requirements using that pattern. I don't think that would be efficient in our case.
Yeah, I think we would definitely recommend that it's much better to have the idle time set to match your workload. There's no point in closing a connection and reopening it to the same server again.
Yep. Yeah, it would be really helpful for us if we could understand what are the deadlock cases, because right now, as Evaristo said, we have been using the system with conserve sockets to true, and we haven't found issues, but we can foresee issues if we set conserve sockets to true, to false, sorry, due to system limitations. So, I mean, we don't want to be doing anything which is totally against the recommendations, but maybe if we know that we are fulfilling the conditions under which the deadlocks will not be found, then we can be, we can be sure that we are not doing anything wrong. So it would be great if we could understand when these deadlocks happen, because we haven't seen them. Actually, we've never seen them, and we have been working with Geode and with conserve sockets to true for quite some time, and we think with high workloads. So yeah.
We probably have more luck getting a complete list on the dev list where everyone has time to think about it, and there's a broader audience. And you're right that it probably would be a great idea to summarize that in the documentation as well.
Yep.
To provide better guidance for all the users.
Yeah, for us, when we thought about this, when we saw in the documentation that conserve sockets was, for our case, was the recommendation was to set it to false, we said, okay, let's go for that. But then we started to run into unexpected situations. We didn't expect so many connections. We didn't expect that the server functions needed to set the value explicitly. We didn't expect that not all server functions needed to do it explicitly. I don't know, we didn't know about these domino threads. So many details that made a big difference. So yeah, I guess it's not easy to document all these things, which are complex, and also the number of connections, how to estimate the number of connections that would be required. That was very, very hard from the documentation. So yeah, it would be great if the Geo documentation could be enhanced with these things.
I think another point you brought up that's worth sharing a little bit more about, which is what it means to run Geode in I'll say a virtualized environment. You used a cloud environment, but the basic thing that's the same across these is that you've got a bunch of workloads running in a mixed environment that you may not have a lot of control over. And there's good and bad things to that. And it really depends on what your objectives are with Geode. If you have certain hard limits on response time and throughput, I think most people will have better luck if they're able to create reserved resources that are dedicated to the Geode cluster itself. As an example, you know, a lot of virtualized environments allow techniques to share memory across different workloads and only page in memory when it's actually required. That kind of pattern is really not great for an in-memory system like Geode. And so we typically recommend that users reserve the memory for the Geode instance, reserve a certain amount of CPU capacity for the Geode cluster, and that ensures adequate response time. So, and you know, I'm more familiar with Geode, but I also see that, you know, being true for other kinds of data products as well. They need the dedicated resources to run at the sufficient rate that you need them to service. So something to think about as, you know, you have these mixed workloads is how to ensure that the Geode is resources are adequately provisioned.
Mm-hmm.
Yes, I think you are totally right. I mean, there, and actually, I mean, we try to provide recommendations about resources, never over provision, book the CPUs, the memory, even the NICs, okay, the virtual NICs. So I mean, I totally agree with you that's critical, okay. But somehow for us the problem is when we go larger, for instance, with this number of connections, it's even hard to predict the number. I mean, with a 50 servers cluster, could be, I don't know, just to be honest, but over 50,000, almost for sure, connections. Okay, worst case, even more. So I mean, it's scary. At least the numbers are, I don't know, are quite big actually. Much more than documented, I would say, at least according to our test. So yeah, somehow it's the best for sure. Looks okay. Buy your big machine and everything for your process. I mean, I agree with that, but probably there are environments. I mean, we usually maybe it's but I don't think it's so uncommon. It's not only Geode. You have other logic around and so on, and many customers deploy in data centers that are not native hardware, right? So if you want your special machines just for the Geode, okay, that's fine, but that's usually something they don't want, okay, because they prefer to manage all the same way, whatever that is, okay. And actually, I mean, that's the trend. But you are right. I mean, ideally, it's best to try to book everything in advance, okay? But it's, at least for us, it's hard. We are the only product in the solution, let's say, trying to do that, and then it's tricky. I mean, so I mean, I think you are right, but on the other hand, I mean, this is the trend, right? So you see Cassandra's in the cloud, you see others similar, and I think that's an interesting path, I would say, even for the Geode. and probably, I mean, it's related with other questions that Alberto raised, but for me, if I think with a blank sheet, I would say that the optimal is not to have 4 connections or 50,000. It's to have something in the middle, right? I would say, or something more, I don't know, that allows you to scale, okay? Because maybe you have the bottleneck in the socket, but 50,000 looks also a bit extreme, I would say, okay, for at least for these environments, let's say. So that's what we were, I don't know, debating internally, and I know it's difficult, but at least to raise the topic. I mean, or maybe it's, it's very hard, and maybe it's as you say. I mean, if you want to run big clusters, then it should be native, and that's it. And then, I mean, I don't know. But more or less, these were also our discussions, the kind of topics we have. I don't know.
Yeah. Fair points. I do know we have I have seen systems with conserve sockets false, with upwards of 100 nodes in the clusters. So it's I don't have details on that, but maybe something worth digging into more.
I don't know if it has been ever considered to have a in-between way between conserve sockets to false and to true, or I don't know. It has never been in the scope. Mm-hmm.
Funny you should mention that. I know of several prototypes that have been done in this area, which is more of a connection pooling approach. Mm-hmm. So rather than having to create a brand new connection for every client thread, it would look for a pooled connection to that server and check one out. Mm-hmm. And I think that approach has a lot of benefits of both models. The challenge is there's a lot of complexity if you look into how we internally look at the kinds of messaging we do between peers, whether it's shared, unshared, ordered, unordered, thread owned, or all these different models, which I'm certainly not the expert on, but that's led to a lot of complexity in trying to look at what it would take to do something like that.
Almost up on time. Anything else we should touch on in this session?
No, I think we got some feedback, and I will write an email to the dev list to ask some of these questions that we have posted here, and let's see if someone remembers or has the information, and then we can improve the documentation, and I don't know. So.
Yeah, sounds great for next steps. Thank you so much for presenting today, Alberto, and always good to see you all.
Okay, thank you.
Very much.
Thank you, guys. Bye.